Assalamualaikum and good morning to my examiner, Professor Dr. Haji Azrina binti Haji Muhammad, and also my supervisor, Sir Razif Samsudin. Today I'm going to present my SESP 650, my final year project, which the title is Users Behavior Observation Using Convolutional Neural Network, CNN. So, the problem statement of my final year project is that for Tamanagar is the well-known local attraction and established since 1928 by the British administrators under the name King George V and National Park. It has been visited by many local and foreign visitors. However, since pandemic spreading worldwide, Tamanagar affected with the losses, especially in financial. To make a promotion about Tamanagar instead of using paper-based materials such as brochure, magazine, and book, and usual multimedia promotions such as on websites and also social medias. I proposed to create a 2D game with a rule-based AI application. So to make it interactive and amusing promotion. So one of the problem statement is that beside of a proposing game prototype, facial emotion detection system prototype also proposed as another alternative for games feedback. So the facial emotion detection system prototype will be using convolutional neural network CNN model. So there are several applications using conventional neural networks such as the Snapchat luxury filters, medical image computing, and Facebook messages filter, and also can be used for to unlock your smartphone and so on for conventional this CNN. So long as it is using for a visual imagery. Um, and the objectives of the project is to identify the first of all is to identify the related information about Taman Negara in Kuala Pahang. And then secondly is to develop a game-based e-learning that implement game-based AI system or rule-based AI system. The third one is to design video processing architecture that perform real-time facial expression detection, which is called a system prototype. So the last one is to develop real-time facial expression detection system or emotion detector. So next one is the scope of the project. Is the platform is game for first of all there are two prototype I will develop, which is the game prototype and facial expression detection system prototype. So for game prototype, the platform is software used is RPG Maker MV. The target user is the output is a software PC. I mean the platform, and the target user is like the user or tourist. So for technique, we will be applying battle and quiz concept, and second one is applying rule-based AI system on battle with NPC. So for facial expression detection system, the platform we will be used is PyCharm integrated development environment IDE, and also the target user will be the game developer, and the technique will be develop three CNN architecture, which is a VGG16, AlexNet, and GoogleNet to classify the emotion dataset. And the last technique is to develop the application for facial expression detection after the best architecture selected. So for research significant, so we know the game prototype is important for both Tamanagar and the users. So the advantage of this research for Tamanagar is to replace the usage of paper-based material for promotion and enhance the method of promoting Tamanagara, and also attract more people or their attentions towards Tamanagara. So the advantage of this research for the user is that they will able to experience the game that implemented with the rule-based AI system or game-based AI system. So for research significant for facial expression detection system prototype is that is important to the game developer. So the advantage of this research for game developer is to enable to obtain the game's feedback by calling the participants to join the game testing before the game is published and marketed. So the result of facial expression detection can be used as a video game promotion along with the gameplay. So there are several phases of the project. First of all is preliminary study, and then knowledge acquisitions, and then I will design the game, then the development of the game, and then the data collections, which is from the online meeting with the gamers or the users, then also system design, and then followed by system development, and then lastly is game and system evaluation. For facial expression detection system prototype, as we know that first of all, there will be a image pre-processing or image data generator, which I will save the image of the facial expressions, and will form the data sets, which is about 39K of that images inside, which is will break into several folders, which is a train and testing data set, and every in the training and the testing data set will be several folders inside, such as angry, happy, and there are 7 types of facial expressions, 7 classes. So this image preprocessing, for train data generator, I am rescaling the image, make it a rotation range, show range, zoom range, width shift range, height shift range, horizontal flip, and fill mode nearest. For testing dataset images, I'm using a test validation data generate, which is rescaling the images only. So yeah, the problem is the difference between the image both image processing is that then data generate and pre-process it become more difficult compared to testing, which is like easier for him to identify that images, specific images. Actually there is changes, train and train testing dataset image, there's a mistake inside. Yeah. So the flow of emotion dataset image classification is, first of all, there's a dataset of emoji images, and then it will go through 3 classification using 3 different architecture: AlexNet, VGG16, and GoogleNet. And I will I will extract the result of accuracy and loss, and it will be used the best architecture, which is the best result for training accuracy and the validation accuracy, and also the training loss and validation loss. So algorithms hyperparameters is there's the details, which is consists of optimizers, momentum, initial learning rate, regularizer, epochs, batch size, and loss functions. Okay, these decisions already been made as already use some ADASME testing by using RMSprop, ADAM, and SGD, which SGD give a proper result compared to RMSprop, prop, and ADAM. SGD have give excellent result, which compared to RMSprop and ADAM optimizer, they just can be performed at the highest learning rate about 0.001. Compared to SGD, it can perform nicely using high learning rate, which is the maximum learning rate is 0.01. So if above maximum learning rate, of course it will produce unstable result or produce undesirable divergent behavior in loss functions. So next is that so the above snippet of code shows the details of the hyperparameters was set up on every architecture algorithm using Python. So this is the details, which is of course the loss function is the categorical cross entropy to classify whether it is a smile, it will happy or angry, and also the loss rate is 0.3 in optimizer. Stochastic gradation with the learning rate momentum 0.9, and Nesterov is turned off to false. So the matrix accuracy, and then regularizer is for L2 is 0.001, and the activation function is LU. So basically most people using the ReLU, but I'm using the LU as the best activation function. And then the result between ADAM and SGD, so we can show that I can show that the result with it. So the difference between it is the performance. Which is SGD is excellent performer. So we can see that the GoogleNet cannot perform very well. It become a divergent. I mean, the unstable result given. And then GoogleNet is a different uh, output, which is there are many output because of there are three outputs: auxiliary, first auxiliary, second auxiliary, and the usual output. Okay, so and then so the result of every architecture for learning rate, the additional learning rate actually is 0.01, but the lowest will show the lowest one. So we can show that VGG16 is the highest for training and validation accuracy, and also for loss. I mean, the lowest. I mean, the LexNet is the lowest, 46.32 and 47.01. And then for GoogleNet, because it actually has a different output, so we know that there are many outputs there. So we know they have about accuracy, they have about 6 output, and loss is about 8 output. So we know the loss output is too huge, too much, about 100%, 117, 121, and 118. So it's highest on highest low training loss and validation loss. So for learning rate 0.001 for accuracy and loss for LXNet and VGG16. So we can show that VGG16 become improve in the loss, training loss and validation loss, with the lowest one 18.43 for training, and validation is about only 14.42. While the accuracy is excellent with 79.81% for training and 86.66%. It's a little bit I can say it's underfit, little bit underfit. So the accuracy for training output for GoogleNet, this is a GoogleNet, but okay, 68.19%, and another output, it shows above 60%. Okay, so for loss is still big, huge. So learning rate for 0.01, the maximum learning rate that SGD can perform is that the highest one is VG16 with validation 92.6% and 87.96%. So for loss is the lowest one for VG16. So it's the VG16 is the excellent performer compared to LXNet and GoogleNet. So you can see that GoogleNet still have a highest loss result, and accuracy is a larger, but we know that loss is also high. So for the summary of the result is that we're going to conclude that VGG16 shows the good result with training accuracy 87.96%, testing accuracy 92.66%, training loss is 10.67%, and testing loss is 8.40%, which is the highest accuracy, and a loss of 10. So however, the time taken to complete the training and testing is almost 24 hours for VGG16. Meanwhile, LXNet and GoogleNet just both of them took only 7 and 6 hours respectively. So there are many factors that affect the result of accuracy and loss. Consists of the size of dataset of images, and then the complexity of image pre-processing or image data generator, and also the quality of dataset of images. So we can see that if the quality of dataset images, which is there are very different type of many different type of faces, or which is give the lowest accuracy. Okay, so I mixed with some easy dataset inside of using DataFear 2013, so to make it like more easier. And the parameter tuning, we can say about the how much learning rate you want to give, and also the epoch. Okay, so and also the batch size. Okay, so I'm using 32 for batch size. It is to low the computational power, power of computing. So I don't want to make my laptop too much high computational power. So I also set epoch for 100, and also 3 learning rate 0.01, 0.001, 0.0001. So the algorithm of CNN, which is the layer, regularization, the value of weight, loss, momentum, instead of accelerated gradient and learning decay. So the more the thick the layers, the more many layers there, you can prevent overfitting. So that the more layer is that, because we instinct is to have the thickest layer because there is many layers there. Okay, and also have a batch normalization to make it fast in training accuracy and training, to make it more faster to run training. So, and also the type of optimization algorithm such as SGD, RMS Pro, Ada Delta, Ada Grad, Adam, and many batch gradation. So those are factors that affect I mean how much it take to train, and also the accuracy and loss. Okay, I mean the size of data set image, maybe if you want to take about, it's good if more than 10 10,000 k 10,000 dataset images. My the total dataset of images about 39,000 like that, and then yeah, the complexity also and so on factor like that. So that's a summary of the result. So the results of users emotion detections for first player, you can say that neutral. Yeah, the most is happy. Yeah, because he always show the face of happy during his online meeting, our online meeting with the first player. So neutral is 42.2%, sad is 8.5%, and followed by surprise, angry, disgust, and fearful. So the feedback also is shown there, and also happy is the majority, and also neutral. For second player, the majority, I mean the biggest percentage is neutral, and then followed by happy. The third one is sad and surprised and angry, and then fearful and surprised. So the feedback and also the level and recall is obtained. And then the third player is neutral, followed by happy, and then sad and fearful. So the feedback is provided there. And then fourth player, yeah, the majority is sad. I mean the biggest percentage is sad, 40.2%. In the neutral, 33.6%, followed by happy. And then also the feedback also provided there. And the last player, player 5, is neutral, followed by happy, and then sad. So yeah, includes their feedback also. So we can summarize that, yeah, they are so neutral. I mean they doesn't show much in their expression, the face, because they are focusing too much on the game. Yeah, but they are giving many feedback about the game. So the next is a game prototype. Okay, so the cover there, as you show the background there, is that my design of the game, or my game development. So the function of rule-based AI system or game-based AI system is the specific name of the rule-based AI system of this game in the game prototype. Okay, we know that rule-based is a more deterministic approach. It doesn't require much data compared to machine learning. They require 110,000 of data to perform classification, clustering, or regulations. In rule-based system, they just require a set of rules and like a little amount of data to solve the problems or find a solution based on the data obtained. So based on this game, a specific set of rules will perform if the data or the state of the non-player character NPC enemies meet the requirement of the set of rule. So in this game, I can show that this is a database of the enemies. I just have to save the data inside the database of the enemies with his traits, which is the skills stored, and also inside the action patterns. Actually, action patterns, I let this empathy to make the the role-based AI system in not tag working perfectly. So action pattern is like almost the same with the not tag inside. I mean rule-based AI system in the not tag. Just is the difference is that it has a limited action can be performed, in which it is performed the action randomly without set up the rules like HP parameter less than 80%, troop alive, remembers the more than 30. It is a command of a rule-based system. So it cannot perform the healing on its team. It can perform on its own. which is just, let's say I want to make it, I want to perform skin acting, it will just give instruction that how probability you will do that action, like that. So that's a limitation of action patterns. Also, the rewards is, let's say if you win against the alter the swordsman, you will get experience 50 500 and gold 500. So also the drop items, you will get sword, shield, and or yoroi shield. Okay, so do not take a JavaScript of a rule-based system or battlecore system.js is the file of the rule-based system. It will improve the enemy's performance, such as healing for its team, attack the character's player based on the specified rules, and which target it should attack, either with highest MP, highest HP, lowest HP, or lowest MP percent. So the both snippet of code, it shows that the left one is the general jargons rule-based system, and generalizable is the right one. So the format of command attack is that state of enemies, and then followed by skill to be unleashed, and then the target. So what kind of example is that? Let's say MP parameters, the enemy's magic point is less or equal to 100%. So my enemies will perform skill 57. I forgot which skill is that, for the highest MP. So let's say there are three character of my characters have lowest MP. The highest MP one will be attacked. So and also another example is random active percent. So it will perform a skill 55 at the highest random. I mean probability will perform that action random, and to the random enemies. So the random target there. That's how it working for this NotTech rule-based system. So picture above right shows the snippet of code of evaluation on the total members dead and alive, and the snippet of command of a set of rules. So the set troop that members is more than 2 is where the player's character only left exactly 1%. This troop that members if more than 2 is actually 3 or 4. Sorry, that's my mistake. That's my mistake. The skill 40, which is a fire or 3, will be unleashed. Let's say troop that members is more than 3 or 4% there. Okay, the fire or 3 skill will be unleashed. The JavaScript code will read a command using regex. Will read my NotTech and apply the command on the NotTech. So we can see that pictures above shows the example of Alter the Swordsman unleash its skill 17, which is a Thunder All 2, which is the rule is troop alive members less than 4, skill 17, random. As there is a player character is dead. Because of my troop alive members is less than 4, just 3 in there, or just 2. No, just 3. Previous 3, because he killed my another character, which is name is Lucius, okay, the doctor one, and then it will perform a skill 17 Thunder All 2, and then it will randomly, because this skill is can take all of my characters, and my precious Lucius dead, another 2 is still survive. So the condition meet the specified rules requirement, and the NPC unleash its skills. From my presentation about about the game prototype and facial expression detection system prototype, I will show you how my interface of my system, and also for both prototype. Okay, that's all from me. Thank you.